Hey guys, I thought I would talk to you for a minute about load calculation. Just some simple introduction so we can get started again on load calculation. I have a couple videos on the Talent 875 channel. I'll probably eventually move them over to this channel just because they're more classroom studying type videos. But for the time being, I was going to talk about heat transmission. Now I was down here in my shop looking at some of my old stuff. Very old pliers. You can see these. Made in Candice, Ohio. Tongs. Been around for a long time. Just like the guy I learned all my stuff from, and that's my father. But he taught me a lot about design. He couldn't service anything. I mean, he wasn't a service tech. He never learned how to service any piece of equipment. In fact, most of the time when you ask him, what's wrong with it, he says probably the capacitor, because that's what he knows about. But he is very good at designing and installing, especially the design aspect. He's designed stuff. The city of Wilmington uses his drawings on their jobs. They don't even get engineers to go over his stuff. They just sign his drawing, and his drawing is the engineer's drawing. So that's who I started learning from as far as load calculation, and couldn't have had a better teacher. Now along the way, you got to figure out what is the best way to figure out your load calculation. What program are you going to use? And I don't really use a program. I kind of, like a lot of the stuff I do, I don't know if you call it anti-establishment, but I don't really use a program. I have a program on my phone that writes off mobile, but I don't use it a whole lot. If I'm on site, I might do something with that, but a lot of times I use the Excel spreadsheet that I've designed for load calculation. But we're going to talk about a very particular part of it, which is figuring out your heat transfer multipliers based on what you want them to be. It's basically designing what you want to happen rather than hitting a drop-down box on a program and going, well, let's see what kind of stuff do I have. You're going to know based on your own design what's happening. And let's take, for example, we have insulation in a wall. You know, we got walls back here. These are stud walls in the back of my shop that have no insulation in them. But a lot of times you have 2x4 stud walls that are R11 or R13, or 2x6 stud walls that are R19. So we have R19 insulation. Let's say we put gypsum board or sheetrock or whatever you want to call it on one side. Let's say it's 1/2 inch or 5/8 sheetrock, and you have sheathing on the outside. Let's say the whole thing, once you figure out your building materials, because you got to research your building materials, see what the R value is, or maybe they give you a U value, and we'll talk about that too. You got to add them all up to see what you got. Okay, so we go with the R values. Let's say our whole wall added up to R16. Well, R16, to get a heat transmission multiplier out of it, we got to turn it into a U value. And all you do for that is turn it into a fraction. 16 over 1 is 16, so we have R16. So all we have to do to that is invert it, and that's your U value. So instead of 16 over 1, we have 1 over 16. So once we have 1 over 16, we figure out what that number is. So we have 0.0625, which is 1 over 16. So let's call it 0.06, just to make it easier to follow. So 0.06. And what that means is how many BTUs will pass through 1 square foot of that building material per hour for 1 degree temperature difference. Meaning you take 1 square foot, you know, just like we're saying, 1 square foot, 12 by 12. That's how many BTUs will go through it if there's a 1 degree difference on either side of that wall. Say there's a 79 degrees on one side, 78 on the other side. You're going to get 0.06 BTUs per hour. But that's not finished yet. We have to figure out however many square feet we have, and we also have to figure out what the temperature difference is going to be. You can either go with a design temperature, like let's say if we're in my area, the outside design in summertime is 91. 91 degrees, and the indoor design is 75. But let's say we have a homeowner that says, well, I want it to be 70 degrees in my house. So you have to design equipment for that particular situation, because the design between 91 and 75 is going to be different than the design for 91 and 70. So let's say we take that 21 degrees. So we're going to multiply 21 by 0.06. And let me add that up real quick in my head. So we would then get 126 or 1.26. So 1.26, and let's say our wall is 1,000 square feet. We have 1,000 square feet of wall. So 1.26 times 1,000 is 1,260. So 1,260 BTUs per hour will pass through that wall based on what we designed. And that's just one example of what we're going to do. But you can sort of see where we're going. We can do that in different aspects, in the attics, all over the house, based on what design we want. So stick around. We're going to do more with this. If this is something you guys want to learn about, let me know in the comments section, the thumbs up section. If you guys think this is stupid or dumb, you hit a thumbs down. You thumbs down this video. Better not give me the thumbs down. I hate them. Make me sad.